So today we're practicing the sum and the difference identities. Okay, basically the sum and the difference identities, we use them so that we can take a angle that is not on the unit circle and use unit circle values to define it. Okay, and there's a couple other things to use it for as well, but that's what we're going to be doing today. So sine of 11 pi over 12. Okay. You could use the half angle identity on this, but since the directions say to use the sum and the difference identities, that's what we're going to do. So the first thing I need to do is I'm going to need to split up my angle because I need to change it into the form of either A plus or minus B to use it. So I know when I split this up, I'm going to get something in this form. Okay. So what we need to do is we need to figure out, well, what could we do to get those to be unit circle values? Okay. So 11 pi over 12 could either be like 1 and 10 as my angles. But the 1 pi over 12 isn't going to help me because that's going to cause me to use, again, either a sum or a difference. So we can't use that one. We could use 2 and 9, and that would help. Or we could use maybe 3 and 8 as well. So there's going to be a bunch of different ways of doing this. Okay? And you can split it up however you want. But I'm going to do 2 and 9 because that seems like that's the easiest right off the bat. Okay? So that means that basically this is sine, and when you reduce 2 over 12, you get pi over 6 plus, and when you reduce 9 pi over 12, since they're both divisible by 3, you're going to get 3 pi over 4. And both of those angles are in fact on our unit circle. So when we do our sum rule, okay, so again, the sum rule says if you have the sine of A plus B like this, that is sine of A cosine B plus cosine A sine B, like that. So that's what we're going to do. We're just going to see wherever we plug in A, we're going to plug in pi over 6. Wherever we see B, we're going to plug in 3 pi over 4. So that means this is equal to sine of pi over 6. Looks like my pen's running out of ink. Pi over 6 cosine of 3 pi over 4 plus cosine of pi over 6 sine of 3 pi over 4. Okay, and now it's just using the unit circle. So what is sine at pi over 6? 1/2. Pi over 6 is 30 degrees, but sine at pi over 6 is 1/2 times cosine at 3 pi over 4, which is negative root 2 over 2, plus cosine at pi over 6, which is the square root of 3 over 2, times sine at 3 pi over 4, which is positive root 2 over 2. So those all just came from our unit circle. Now we multiply them. So we're going to get negative root 2 over 4 plus the square root of 6 over 4, which is negative root 2 plus root 6 over 4. And that's our answer. And that you cannot subtract those things or add those things. Okay? You cannot put those two together. Just leave it like that. Okay? That's it. That's the sign at 11 pi over 12. So we're just using the identity. The hardest part of this one is splitting up that fraction and getting two fractions from the unit circle. All right? Next one, cosine of 105. Now, there's going to be a ton of ways you can do this. Okay? So, for instance, what's one way I could get 105, either by a sum or a difference? Yep. You could take 60 degrees plus 45 degrees. That's one way. You could do 150 minus 45 degrees. That's another way. I mean, there's going to be a ton, but those would probably be the two easiest, okay? So you could either do it as a sum or you could do it as a difference. Does it matter? Not really. So I'm going to keep it simple and I'm going to do 60 plus 45. So this is cosine of 60 degrees plus 45 degrees. So again, this is A plus B. And you just go to your formula chart, and the formula chart says when you're taking cosine of A plus B, that's going to be equal to cosine of A, cosine of 60, times cosine of B, which is 45, minus sine of A, which is 60, sine of B, which is 45. And now again, we just use our unit circle to help us out. So cosine of 60 is 1/2. Cosine at 45 is the square root of 2 over 2. Minus sine of 60, which is the square root of 3 over 2. Times sine of 45, which is root 2 over 2. Which gives us the square root of 2 minus the square root of 6 over 4, which is very similar to our last answer. Okay. Now the last one is real easy. It gives us this. Okay. Now we're working this one backwards. Basically, this one's the same as the one we just did, except we're working it backwards. So the first thing we have to look at is this is either one of my sum or my difference equations. Which is it and of which one? Well, the first way I'm going to be able to tell is that in both of these terms we have sine times cosine, which means I'm dealing with a sine sum or difference. And since it's plus, this is my sum for sine. This is sine A cosine B plus cosine A sine B. And my formula chart says that's equal to sine of A plus B, like that. Which means what I have here is going to be the sine of 35 plus 10. Because 35 is A and 10 is B, so we plug those in. That means we're looking at the sine of 45 degrees, and from the unit circle, that's root 2 over 2. So this is equal to this. That's it. there's the sum and difference. Your code for today is 2F4 ST4U exclamation point.